Hi, this is Vijayakumar, Assistant Professor, Department of Physics and Head of the Department, SNS College of Engineering. So the Unit 2 Laser and Fiber Optics, the Semiconductor Laser and its applications. Introduction of Semiconductor Laser becomes a solid-state laser based on a semiconductor gain media. So the LD is a laser diode. It device that causes laser oscillation by flowing an electric current to semiconductor. The mechanism of light emission is the same as a light emitting diode LED. When the two meet at the junction, the electron drop into in a hole and the light is emitted at the time. The electroluminescence is the basic principle behind the operation of a semiconductor laser. One is direct band gap and another one is an indirect band gap. This becomes direct band gap semiconductor or recombination of electron and holes take place directly by the emitting of photon. These are two types. The one is in a homojunction and another one is in a heterojunction. So homojunction semiconductor laser construction we discussed. First one, the active medium is in a PN junction made of a gallium arsenic. The P region and N region in the diode are obtained by doping germanium and tellurium respectively in gallium arsenic. The thickness of PN junction layer is made very thin, typically of order of few micron, and the N phase of the crystal are made partially reflected from an optical resonator. Electric current is applied to the crystal through metal electrode fixed on its upper and lower surfaces. This is a block diagram of homojunction. The P and N region is a form of in between active regions. Two metal contact is connected from outside of the external power supply to the form of forward bias. So the energy level diagram, population inversion is achieved by injecting electron across the junction from the N region and the P region by the mean of a forward bias voltage applied across it. The recombination of electrons and holes in the region result in the emission of photon. The process is spontaneous and the laser radiation is random and incoherent. But this photon triggers the stimulated emission of photons to get generated by increasing rate of recombination of electrons and holes. Current density is increased, the emission becomes more and more the coefficient and the radiation intensity increase. Wavelength of emitted light radiation depends upon the concentration of donor and acceptor atom in gallium arsenic and also on the energy gap of the particular semiconductor. So the assignment, what is the principle of semiconductor laser and distinguish between homojunction and heterojunction, why gallium arsenic is used in a semiconductor laser. This is the second one, homojunction and heterojunction semiconductor laser. So the multiple layer is form of N type and P type in a different layers and between two form of metal contact to the connected in a forward bias region. Heterojunction laser is a high efficiency when it's at room temperature. It composed of various doping combination of gallium arsenics and aluminum gallium arsenics. The thickness of active region is 0.1 to 0.2 micrometer thickness. Aluminum gallium arsenic layer on both sides serve as potential barrier and provide confinement for charge carrier to flow within the active regions. The existence and recombination radiation can occur only within the active regions. Due to multiplier in the laser structure carry are confined to a narrow line, the population is built up in a lower current level. The operating current level is less than 50 milliampere The light emitting wavelength in the active region is 1.1 to 1.6. Characteristics: it is a solid state laser. Active center PN junction diode. Pumping method direct conversion. Power output 10 milliwatt. Nature output continuous and pulse. Wavelength 8600 to 8300 to 8500 Armstrong. Advantages: it is a very small in dimension and arrangement is simple and comfort. Disadvantages: usually in the form of white beam. Monochromatic priority stage. This is also application of lasers. This is a reference I prepared from the PPT of semiconductor laser. Thank you very much. We discuss the next topic in next video.